Alright guys, so this is the second half of our Module 8 study guide video, so I hope you have it in front of you. You should also have a pencil and a multiplication chart if you think you need it. So for number 4 and 5, we have fractions, and we are multiplying them either by a mixed number or an improper fraction. So some kids have asked, Ms. Ogle, what's that crazy dot mark? Well, that dot mark, simply put, is another way to write the multiplication sign, and that's not the first time we've seen it. So when I set up my problem, I'm taking 1/5 times 2 3/4. But we had mentioned one of the strategies we could utilize when multiplying mixed numbers is let's not keep it a mixed number, let's convert it to an improper fraction. So my shortcut was to multiply and then add. So 4 times 2 is 8. 8 plus 3 is 11. So now I have two fractions, and I can just multiply those across and rename if necessary. So the same thing with number 5. I have 10/3, and I'm multiplying that by 2 1/2. So let's get rid of that mixed number there, and let's turn that into halves. So take a minute, calculate how many halves that would be. And then go ahead and write your number in there, and then you're ready to multiply across and rename if necessary. Number 6, there's two ways to solve. As we learned today in class, it is a classic scaling question. Ms. Romano is planting 2 flower beds. Below are the dimensions for each flower bed. Is the value of the area larger or smaller than 4 square feet for each flower bed? So here in flower bed A, I have 4 times 1 1/2. Would my product be greater or less than 4? That's a scaling question. My second flower bed, I have 4 times 4/5. So I have a whole number times a fraction. Would my answer be greater or less? We can do this mentally. If you're kind of stuck on that, go ahead and solve it the old-fashioned way. And problem 7a and 7b are very easy, but it looks a little overwhelming just because we have so many different parts. If I look, it says a recipe for sugar cookies makes 3 dozen cookies and calls for the following ingredients. So it lists all the ingredients that you would use. Now, how much of each ingredient is used to make 4 of that amount? 4 of those 3 dozen cookies. So when I look at butter, and I'm going to write this really, I'm going to do like 1 or 2, kind of set it up for you, and my room is not as big as yours. But if I look for butter, butter is 1 cup, 1 whole cup, and I want to make 4 of those. So how many cups of butter would I need? Yeah, 4 cups, right? Now, if I look at sugar, I'm going to write it off to the side here, and I'll even change colors. I'm going to draw a little arrow. Okay, so sugar, if I look, is 1 1/2. And remember, I want to make 4 times that amount. Okay, so that's a mixed number times a fraction. I can do that. So 1 1/2 means that I have, let's see, that's multiply and then add. So that's 3 halves times 4. Put that over 1. Beep, bop, boop.
At this time,
12 halves, which I can rename to 6. So for the sugar, I would need 6 cups. So, because I'm making those 4 recipes, I know each of these ingredients I'll have to quadruple times 4. Now, look, jumping down to 7b, notice, same ingredients, only now I want to know 3/4 of that particular recipe. So I'm making a smaller amount. So going back to butter, I know I needed 1 full cup for the regular recipe, but I only want to make 3/4 of that. So, okay, well, if I do 3/4 of 1 cup, let's put 1 over 1, multiply across, guess what? I only need 3/4 cup of butter. And conversely, let's do sugar. So here's sugar. I'm gonna put sugar over here for more space. Remember, sugar was 1 1/2. And now I only want to use 3/4 of that. So I know 1 1/2 is 3/2 times 3/4. So that's 9/8. And I rename that. 8 goes into 9 one time. I would have 1 left over, and it's 1/8. So I would only need 1 1/8 cup of sugar if I made a smaller amount of that recipe. All right, so I know you have quite a few to calculate, but it's very similar types math for all of them. Good luck, guys.